Welcome to Best Pallet Software, the most user-friendly and affordable yet sophisticated pallet design and structural analysis software. Best Pallet has three main portions: the input screens, view edit screens, and analysis screens. Best Pallet can be operated in English or Spanish by using the switch in the lower left-hand corner, as well as US or metric units using the switch in the lower right-hand corner. The design process begins with either a stringer style or block style pallet. You can begin the design process by selecting one of the two buttons at the bottom of the screen or the next button. On the pallet styles input screen, the user is able to select either a pallet or skid style, two-way or partial four-way, reversible or non-reversible, flush, single-winged or double-winged, new lumber, a combination of new and recycled lumber, remanufactured, or repaired. On the lumber input screen, the user is able to specify the lumber species mix, lumber grade, and moisture content associated with the desired pallet design. Component groups can be separated by using these buttons or by manually dragging and dropping. Once component groups have been separated, in this drop-down menu you will see you have the ability to specify a lumber species mix of up to 3 different species and the percentage breakdown of each for each component group. Furthermore, the user has the ability to separate exterior and interior components using the checkboxes here. Used and recycled material can also be specified with all species, all hardwoods, or all softwoods. And the lumber species selection map can be used to filter the desired species for a particular region. On the stringer input screen, the user is able to specify the quantity of stringers, the uniform stringer height, the width of each stringer, and if partial four-way, the dimensions and locations of the notches. Users are also able to specify the location of stringers either manually or numerically. Staggered fastener placements as well as asymmetric stringer design are also options. On the top deckboard input screen, the user is able to specify the quantity of deckboards, the width of each deckboard, the number of fasteners per connection, the uniform thickness of the deckboards, and locations either manually or numerically. End boards can be butted, corners can be clipped, and asymmetric top deckboard design is available. A lip can be added to the pallet design where the end boards overhang the ends of the stringers. On the bottom deckboard input screen, users are able to specify the quantity of deckboards, the width of each deckboard, the uniform thickness of the deckboards, and the number of fasteners per connection. Deckboard positioning can be done manually or numerically. Bottom deckboards can be chamfered, and asymmetric bottom deckboard design is available. Once a pallet design has been completed, the user has the ability to specify the specific fastener being used as well as predict the pallet durability. The fastener type can be selected from the drop-down menu, and once chosen, the fastener data can be input into these fields. If the MyBand angle is unknown, it can be designated based on the wire diameter. Different fastener specifications can be entered for the top and bottom deck, and for block pallets, mat fastener specifications can also be input. Once a fastener specification has been completed, it can be saved to a durability file that can then be retrieved for use with future pallet designs. Once pallet cost has been input, a durability assessment can be performed, predicting the cycles the pallet can withstand prior to its first repair, as well as the number of cycles the pallet is predicted to withstand after properly repaired, in addition to the relative damage rate and relative damage severity, which are clearly explained by clicking on the check mark box. On the loading conditions input screen, the user is able to specify a particular package or product, the required payload, whether the load is full uniform coverage or partial uniform coverage. If partial, how much underhang exists in the concentrated load, the load variability, the stacking pattern, and any load stabilizers being used for the design. The storage and handling conditions input screen allows the user to specify the specific ways the pallet will be supported and handled throughout the intended supply chain. This includes free-span racking, warehouse floor stacking, and handling with forked equipment. The checkboxes to the left of each support condition enable that support condition as part of your structural analysis. So be sure not to check mark any that do not apply to the specific or intended supply chain. The checkboxes to the right of each support condition show you the three-dimensional portrayal of the pallet in that support condition. This, of course, includes warehouse floor storage and handling with forked equipment in both directions. For each of the support conditions, the free span and the bearing area can be adjusted, as well as for forked equipment, the length, width, spacing in between, and thickness of the fork tines. The View Edit portion of the software allows the user to view the pallet in all orientations, as well as manually manipulate the view using the tools in the lower left-hand corner. Coloring can be added to the pallet, beginning with using the cursor as a coloring tool or an erasing tool. Component groups can be colored, as well as mirror faces of components. The color selection tool can be used to select specific colors, or colors can be copied from an existing pallet design. Additionally, custom coloring can be added for fasteners, deckboard edges, and stringer edges. Stencils, as well as stamps, can be applied to your pallet. The sizing and positioning can be adjusted, as well as the font. The user also has the ability to design mixed truckload shipping layouts. First, the desired shipper is to be selected, and then pallet designs can be populated one at a time in the order they will be loaded by first specifying the quantity of each. Once a mixed truckload shipping layout has been saved, it can be retrieved. The analysis section of the software begins by entering company information that appears at the top of all output screens. A three-dimensional specification is provided with custom note fields at the bottom, as well as a two-dimensional specification with custom note fields on the right-hand side. Two-dimensional schematics, as well as three-dimensional schematics, are also provided, and a structural analysis that provides the predicted maximum safe load or strength, initial average deflection or stiffness, and critical member for each support condition specified by the user. The critical support condition is compared to the payload. 8 fundamental alternate pallet designs can be generated using this tool in an attempt to better satisfy the payload for the support condition specified. A cut list can also be generated for production runs, where first a quantity is entered, which then updates the cutting bill information for all of the components. And this can be exported to Excel to then enter pricing information. A detailed fastener specification is provided if the user input a fastener specification, as well as a durability analysis. Durability comparisons can be made using this tool between the same pallet using 2 different fasteners or an existing pallet design compared with a different pallet design. Durability comparisons can be made for all deck boards together, top deck boards independent of bottom deck boards independent of top deck boards. Once a comparison has been made, column headers can be edited on the data table. All output screens can be printed to a physical printer or a document writer. Simply select the screens you would like to print and print selected. Block pallets can be designed by first entering the length and width, the use category, and the treatment for export. The style of the block pallet bottom deck is chosen between perimeter, unidirectional, overlap, reversible, and skid. Simply check mark the associated box for the design preferred. If the user needs to reorient the bottom deck 90 degrees relative to the top deck, simply use the turn button. The lumber input screen functions the same way as the stringer input process with an additional component group. The quantity of blocks can be specified from 4 to 36 simply by check marking the box associated with the quantity desired. Block dimensions can be specified, including the uniform height, the width of each block, and the length. Asymmetric block design options are available relative to the length or width of the pallet. Block locations can be specified, including wings and cantilevers. You can see now this perimeter-based block style pallet has a 2-inch single wing and a 2-inch single cantilever. Stringer board dimensions are specified, including the stringer board thickness and the width of each stringer board, as well as the location. The top deck board input screen functions the same way as the stringer input screen, aside from now the user has more than one type of fastener. After the top deck board dimensions, quantities, and locations are specified, the user then has the ability to specify the quantity of fasteners per type of fastener connection. The bottom deck board input screen functions similarly to the bottom deck board input screen for stringers. However, in this case, it is a perimeter-based style block pallet, where the width of the butted boards can be specified, as well as the end board width and the uniform bottom deck board thickness. Finally, the user is able to specify the quantity of fasteners per connection for their block pallet design. Fastener specifications can be input similar to stringer pallets, where a different fastener can be specified for the top and bottom deck boards. However, mat fastener specifications are also possible for block pallet designs only. The loading conditions and storage and handling screens are the same for block pallets as they are stringer pallets.